Hello everyone, let's start solving today's Leetcode daily challenge question. Before that, I would like to tell you that I have created a playlist of streams, Java 8 feature, and there's a playlist for perfect sum bit manipulation. And in the next week, I'm going to upload JavaScript videos also. Not the JavaScript concepts, but small projects which will clear your basic understanding of JavaScript and stay updated. Okay, let's solve this question. So the question is best sightseeing pair. You are given an integer array values where values of I represent the value of ith sightseeing spot. Two sightseeing spots I and j have a distance j minus I between them. Okay. The score of pair of sightseeing spot is values of I plus values of j plus I minus j. And the sum of this is the sum of the values of sightseeing spots minus the distance between them. Okay, so we have to return the maximum score of pair of sightseeing spots. Okay, so if we see the first example, 8, 1, 5, 2, 6. Okay, and these are the values and output is ln. How? If we consider I is 0 and j is 2, and values of I plus values of j plus I minus j, this is what we have to calculate, right? This is the score of pair I comma j. Then we will get the 11. This must be the maximum one. Or else, if we see this example, we'll check with the other values also. 5, 2, and 6. If we, what happened? It is one. Just a minute, I'll refresh. Yeah. So here, if I consider I as 0, that means the value of I at this position is 8 and j as 1. So the value is 1. So what will be our 8 plus 1 plus I is 0 minus j is minus 1. So which is equal to 8. So this is one of the possibility. Similarly, we have 8 plus 5, 8 plus 5 plus 0 minus 5 is at what position? 2 position. So 2 is equal to 8 plus 5 is 13, 13 minus 2 is 11, 11. So like that we have to calculate all the things and we have to return what maximum score of a pair of sightseeing spots. Okay. So what will be the brute force approach? Brute force approach will be what we'll use a two loops like this for int I 0 to I less than values, let's say n I plus plus, and again we'll use another loop for that j for j. Okay, and then we will check with all the pairs where j will start from I plus 1 and we'll check. Okay, this will be the brute force. But if you try the brute force, its time complexity will be what? N square, O of n square, right? But this is like it will give a time limit exited if you submit this solution. So we will see for the next possible approach is if you consider this example. Let's take this example. What we want to maximize, maximize the values of I plus values of j minus plus I minus j. Okay, so can I split it into two parts? That is values of I plus I and values of j minus j. That means this is the left part. Left is I, as I is less than j. I can say this is the left part and this is the right part. We have to maximize both so that we'll get the addition of these two as the maximum. Okay, so if we see this same example, I will consider 8, 1, 5, 2, and 6. Okay, I want the left one. Okay, for left one, what we have to do is values of this my plus its index. Okay, so I'll write 8 plus 0 is 8, 1 plus 1 is 2, 5 plus 2 is 7, 2 plus 3 is 5, and 6 plus 4 is 10. So you'll get the left one. This is what this is. This values of I plus I. Now let's calculate values of j minus j. So what will be the right? Right is okay. Right is 8 minus 0 is 8. 1 minus 1 is 0. 5 minus 2 is 3. Again 2 minus 3 is what? Minus 2 minus 3 is minus 1. And 6 minus 4 is 2. So we'll get this left and right. What we want to do? We have to maximize this left and right. But how? What is our condition? Our condition is I should be less than j, right? So I can combine this 8 with all this, right? This is what we have seen in what, in our for loop to n square time complexity approach, which we have seen earlier, right? Brute force approach. With this 2 I can combine with this I can combine with this I can combine with this, okay, this I mean this I can combine with this. So instead of that, what we can do, can I maximize left if it is a 8, and as we have want left plus right should be maximum, so both should be maximum, but how? For this 8, okay, in this we want a maximum one, that is 3. 8 plus 3 is 11, our answer is 11. Okay, and if you consider 2, 2 is not like it is the less value, right? If we consider the 8, it will be better. For 7 also we have to consider 8, because the maximum is 8 as we are doing the addition. Okay, so that we have to see. So what we can do is, let's consider, let's consider this as, from left what are the maximum values. If we convert this thing to, from the first 8 is there, 8 and 2 which is maximum 8, 8 and 7 which is maximum 8, 8 and 5 which is maximum 8, and 10. And the second one we'll keep it as the same, 8, 0, 3, minus 1, and 2. Now, as I is less than j, so we can, what we can do is we will check this plus this in one iteration. 8 plus 0 is 8. 8. Now this 8 plus 3 is 12. No, 11. Okay. Now this 8 plus minus 1 is what? 7. Now this 8 plus 2 is what? 10. So out of this, which is maximum? 11. So our answer is 11. So in this way, we can solve this question. Let's start coding. Okay. What we want, first we will see, like, consider this as I'm solving in interview, so that I will go from the brute force approach to the optimal one. Okay, so let's, what we now discussed is we want left and right, and we have to we, for left we will what do, maximize its value. That means we will store the maximum value and check with this. So let's consider first int n, which will be the length, values dot length. Then int left I'll take, new int n. We are going to optimize this also. Okay, we are going to avoid using this array extra space, but first let's see what we discussed. Okay, now, hmm, now what will be the first its value? It will be same, right? Values of 0, because what is left using this formula, and for I is 0, it's a value of 0 only, values of 0, and for right of 0 it is also values of 0. Now for int I is equal to 1, I less than n, I plus plus. Okay, here what we want to do is we want to maximize left of I is equal to math dot max of left of I minus 1, comma, this values of I plus I. Okay, and what will be the right of I? Right of I will be the same thing, that is right values of I minus I. Okay, so we are using the same for loop, so I'm using same variable I. Okay, now we got our two array, but what we want to maximize what, this left of I with right of I plus 1, or instead what we can say, right of I and left of I minus 1. We want to add and get the maximum one. So I'll use one variable int max. Okay, let's say I'll set the minimum value, min dot value, and do this thing. Max is equal to mat dot max of max, comma, right of I plus left of I minus 1. Okay, so I'll get the maximum one. Okay, return max. So I'll run this. So here what we did is we calculated first this left. Okay, just a minute, I will comment this. Yeah, yeah. So here first what we did, we calculated. Yeah, here you can see accepted. So first what we did, we have calculated the left and right. Okay, And what is the left and right is we have two formulas, you can say values of I plus I, values of j minus j. This for this we have split it into two parts, that is values of I plus I and values of j minus j. Okay, and then we have calculated this thing that we will store the maximum value from the left in the left array, and in the right array we are just storing the values of I minus I. And at the end we are finding the maximum value of right of I, that means right of this I and left of I minus 1, because our condition is I less than j. And as we are storing here the max value from the left, no, we are not missing any what possibility. Okay, so if I submit this, yeah, here you can see it is this solution is accepted but not the optimal one. Okay, not you can see here how much time it is taking, 6 milliseconds. Okay, now let's optimize this code. That how we will optimize this is you first, I'll remove this. Okay, or let's say let it be. Okay, here you can see for the right one what we are doing, we are just using it somewhere here. We are not dealing with I minus 1, right of I minus 1 or I plus 1, right? So can I remove this right of I with this value directly? I can, right? And this remove the right of I, and this right, I can remove the whole right array only. Okay, now for the left what we are doing, we want the left, what previous left. Okay, so for the previous left, what we can do is, let's say I have one variable, I'll declare one variable as int previous left, okay, is equal to values of 0. And I will just remove this, and instead of this left of I minus 1, I will place this previous left, okay, and instead of left of I'll use the current left. So because we are using only I and I minus 1, so I am replacing I minus 1 with the previous left and I with the current left, and we have to update the previous left, right? Previous left is equal to current left. Okay, so let's run. If we, let's see, okay, it is giving some wrong answer. Let's see what we have done wrong. mm, just let me see. Just control Z will do. Okay, let's run this. Let's check with the right of I. Yeah, now we will slowly review this. There must be some issue. Okay, instead of left of I minus 1 here, okay, let's see, let's use, yeah, here also you can see here left of I minus 1 is there. So we have to replace this also. We missed this. So that is why we are getting the wrong. So int previous left, okay, is equal to values of 0, and previous left we have to replace with both here also and here also. Okay, and here with this left of 5 we have to replace it with the current left, and at the end again our previous, for previous left is current left. As we are maintaining the variable, we have to do this. Okay, let's run and check if it is working. Yeah, yeah, now it is working. So let's optimize some more. Is let's first remove this array because we won't be needing this, right? So instead of this current left, where I'm using, am I using in this? No, right? So why do I need a current left here only to set it up? So instead I can use this, and I can put this, okay, and I can remove this. Is it okay? Yeah. And one more thing, instead of this previous left, you can again put this thing. But the thing is, you are maintaining this previous left again. So that is why it's better you keep this as a separate variable and store this. Okay. So in this way, let's submit this. So in this way you can optimize our solution. You can see like time got reduced and it beats 89.46%. Before it was some 10% and all. Okay, with the same approach, but we were using different arrays and calculation and all. So here you can use this approach to solve this question. You can say this is a DP kind of thing, but not a like what you have seen in DP is different approaches, 2D array, 1D array and all. So this is a space optimized one. Okay, DP approach. So thank you so much for watching this video. If you feel this video is helpful to you, like this video and subscribe my channel. Stay updated.